Alright, in the last video we talked about these rate laws, which are going to give scientists information about how something changes compared to the rate, like the concentration to the rate, and then we also are going to do concentration to time. But for now, let's just go over an example here. So you can see that the concentration of A went from 1 molar to 0.5 molar, and the rate went from 8.4 times 10 to the negative third down to 2.1 times 10 to the negative third. So what that means is that if we go backwards and double the concentration of A, it's going to quadruple the rate of the reaction. So what that means is that the concentration compared to the rate is going to be second order. But let me show you how to calculate that so you can figure it out. It's called the method of initial rates, and the way you know that you're going to do this is because they have to give you a data table with all of this information. So notice that we have our reaction, and so here's our reaction right here. And we have initial amounts of the NH4 plus and the NO2 minus. So first of all, remember we're only focusing on the reactants because we're going to do this right at the start of the reaction where we don't have the reverse reaction happening, and so we don't really have any products yet to talk about, so we're just focusing on the reactants. And notice that they have 3 different experiments. They're showing the initial concentration, so they varied the concentration of these 2 reactants. And depending on the concentration, they could measure the rate of the reaction. And we'll talk about later how to measure that rate of the reaction using Beer's law. Okay, so what you're going to do to solve for this, so we have several variables. So first of all, this is going to be the overall equation, is that the rate is equal to this K, which is the rate constant for that reaction, times the concentration of one thing raised to a power, we're going to call that power N, and then we also have another reactant raised to a different power. So we're going to use N and M for those 2 powers. So what we're solving for here, we're going to solve for K and we're going to solve for both N and M. And that way, once we have all of those variables, we can plug in any numbers that we want and solve for the rate. So we can choose any concentration of these 2 reactants and we can know what the rate is going to be. So what you want to do for this is to choose 2 reactions where you have the same concentration for one of the things, because what happens is it's going to cancel out. And I'm going to do the work over here so you can see it a little bit clearer. So I have it written on my notes there, but I'm going to work through it over here. So I'm going to choose experiments 1 and 2, because notice that right here, these are the same, and so what's going to happen is they're going to cancel out. And we're going to set these 2 up as a ratio, so we're going to set them up as fractions. And what you want to do is to put the bigger number for the rate on top so that you get a whole number. You can do the math with decimals, but it's just more complicated. So if you look at our 2 rates right here, we're only going to focus on experiments 1 and 2. Check the exponents too, but -7 is the same, so the numbers 2.7 is bigger than 1.35, and so we're going to put the first, we're going to put 2.7 on top. So we're going to do experiment 2 over experiment 1. Alright, so for experiment 2, this right here is the overall equation. So we're going to put the rate, which is 2.7 times 10 to the negative 7th moles per liter. And then divided by 1.35 times 10 to the negative 7th. Okay, and then rate is equal to K, so for both of these we're going to have a lowercase k, times the concentration of the first thing raised to N, and then times the concentration of the second thing raised to the M. So you have to be real careful, make sure you keep your experiments straight. So on the top of our fraction we have experiment 2. This first one we're going to put as NH4 plus, and the second one is going to be NO2 minus. So for the second experiment, NH4 plus, we have a concentration of 0.100 molar. And then we don't know what that N is just yet. And then for the NO2 minus, for the second experiment, we have 0.010 raised to the M power. All right, and then the bottom, we have the first reaction. So we're going to go back up to the first reaction. NH4 plus is 0.100 molarity. And for NO2 minus is 0.0050. All right, and now, because we chose 2 experiments that have the same concentration, 0.1 and 0.1 are the same thing. So these are going to cancel out because it's like putting 3 over 3, it's just going to be 1. Same thing with K. K will cancel itself out because it's on the top and the bottom. And so now we can do this math, and you can type it in your calculator if you want. The 10 to the negative 7th is going to cancel, and you can probably see 1.35 times 2 is 2.7. So 2.7 divided by 1.35 is going to give you 2. And then over here, again, this should be to the n power as well. Over here, you can do this math if you need to, 0.010, if you can see that that's like 10, and this is like 5, so 10 divided by 5 is 2. So if you type those two decimals in your calculator, you're going to get 2 as well. And then it's raised to some power m. And the numbers are going to work out where, for this class where you'll be able to tell what that exponent is going to be. So you don't have to actually solve for it. You can figure out 2 equals 2 raised to an exponent. That exponent has to be 1, and it's almost always either 1 or 2. And so in this case, we now know that m is equal to 1. So we can say that it is first order with respect, this is the terminology they use, with respect to NO2 minus. All right, then we're going to do that whole thing over again, except this time we're going to choose the other two that don't cancel out. And you don't have to do it twice where it cancels out, it just makes it easier. Now that we have one of the exponents, let's say that the other two, there wasn't a way to make it cancel out, you just have to plug in all of the numbers, but since you have one of the exponents, you have enough information that you can solve for it. But this one, we can actually compare these two that will cancel out. So now we're going to compare the second and third experiments. Again, you want to put the bigger rate on top. So in this case, we're going to put experiment 3 on the top. It's helpful to label it too so you don't get confused about which experiments you're putting. And we're going to put experiment 2 on the bottom this time. So this one is 5.4 times 10 to the negative 7th. And we have 2.7 times 10 to the negative 7th. And then we have k for both of them. We're going to put NH4 plus in these first parentheses, and then we're going to put both of these were the same. 0.010 molarity for NO2 minus. And we even know that exponent. So we could even plug in m here is going to be 1, and that's going to be 1 because we already solved for it. And let's go back and look at our data. Here we had 0.1 for the second experiment and 0.2 for the third experiment. Okay, so now we can cancel a bunch of things. K is going to cancel. These two are going to cancel, but they don't have to because, again, we know that exponent now, so we could plug that in. And you can go ahead and do that math. You might be able to see it in your head. 5.4 divided by 2.7, these 10s are going to cancel, is 2. And 0.2 divided by 0.1 is also 2. So now we know that n is going to equal 1, so we can also say that it is first order with respect to NH4+, because that is the exponent on NH4+. And then to get the overall order of the whole reaction, you just add them. So right here, the overall reaction order is the sum of all of your exponents. So we have 1 and 1, which equals 2. And so for the final answer for this one, we can say that it is a second order reaction. And then the last thing is sometimes they want to know what is the value of K. So what you can do is now that you know everything in, back up to this one right here, now that you know everything here except for K, you can choose any of the experiments and just plug in all that information. So you're going to plug in the rate, plug in the concentration of NH4+, plug in NO2-, you know that N and M are both 1, and then you can solve for K. So just plug everything in from any of the experiments. And your K value might be slightly different from the back of the textbook because if you choose a different experiment, it's real life data is what they usually give you, so it's not going to work out perfectly. Your K might be slightly off from the textbook because you chose a different experiment, but that's okay because that's just real life. It's going to vary just a little bit. And that's it for 12.3.